Okay, so we are going to look at an example using compression and stretch, so stress and strain. And this problem reads, by how much does a 65 kilogram mountain climber stretch her 0.8 centimeter diameter nylon rope when she hangs 35 meters below a rock outcropping? So let's imagine that we have this mountain climber. Here's the mountain, and she's just sort of hanging out there holding on to her rope. Hanging there. All right. So this is going to use the idea we're interested in a change in length of that nylon rope. And when we look at stress and strain, we know that it's related to 1 over the Young's modulus for that material times the force per area of that that's acting on that material times its original length. So we need to determine and look up actually what Young's modulus is for nylon. That's something that we have to look up. And we can find that the Young's modulus for nylon is 5 times 10 to the 9th newtons per meter squared. We also have to assess, well, how much force is acting on this rope? Well, if this mountain climber is just hanging there, and we looked at a free body diagram of the mountain climber, we would see that she experiences the force of gravity, so that's mg, and she has that tension in the rope that's holding her up. Well, that's the force that that rope is experiencing. So if she is not changing her motion, if she's just hanging there, the tension in the rope and the force of gravity are the same. So the force in this case is that tension, which equals mg. And for our mountain climber, she's 65 kilograms times 9.8. That gives us a force of 637 newtons. We also need to determine the area that that force is acting on, so the cross-sectional area of the rope. So we know ropes tend to be, we're going to make an assumption that it's cylindrical. So the area is going to be pi r squared is our calculation. We're given that the diameter of the rope is 0.8 centimeters, so 0.4 centimeters in radius. So we have pi times 0.004 is 0.412 would give me meters squared. And so I get 5.03 times 10 to the negative 5th meters squared as my area. And then the original length. We are given the original length of this rope as 35 meters. Just hanging on our 35-meter rope. So now that we understand what each piece of this equation is, we can simply plug in our variables, our values for each one. So we have 5 e to the 9th as Young's modulus. Our force is 637 over our area of 5.03 times 10 to the negative 5th times our original length of 35 meters. And when we use those values, we end up with a change of 0.0886 meters. So 8 centimeters that we're stretching that nylon rope. All right, so recognizing where each of those variables go is important. Understanding that that force that the rope is experiencing is equal to the force of gravity of that mountain climber because she's at rest, hanging there, and then using our appropriate relationship. Right, good job.